Welcome to lesson 8.3. In this lesson, we're going to be finding volumes of solids with known cross sections. Now this is going to be a little weird to work with, but I've got some internet sites, some apps that we can use to try and help you visualize this new idea. So let's start with this. Calculus allows us to find volumes of solids whose bases are two-dimensional regions. So, for example, what we were doing last chapter, where we were finding the area of that is a two-dimensional region, a length times a width. So this is the base of the object, and then whose heights are formed by cross sections that stick out from the base. So, for example, triangles. And you get this like 3D shape going here. Now, this is kind of hard to visualize at first. So with each problem, we're going to go into an app using GeoGebra to try to visualize what this is talking about. But we're using an area base, and then we're using calculus to say there's a shape on top of this base, and we're going to find the volume of that 3D shape. These are the most commonly used cross sections, and you're going to want to memorize these formulas. Area of a square, rectangle, semicircle, triangle, and an equilateral triangle. Those are the cross sections that are most commonly used. So here's what we have. If we want to find the volume of these 3D objects, we're going to take the integral of the area of the base. So I'll say that again. If we want to find the volume of these 3D objects, we're going to take the integral of the area, and then that's going to give us the volume. So let's start by looking at number 1. Find the volume of the solid whose base is a triangle bounded by y equals negative 2x plus 2. And then we have x equals 0 and y equals 0. So here's our base, and whose cross sections are squares perpendicular to the x-axis. So to help you visualize it, I'll try and draw this up first. This is the base of our square, and then essentially we have a really big square that sticks out from that base. And as we go, the base of our squares is becoming smaller. So we end up with this 3D shape. Now, let me try and help you visualize this a little better. Here's that shape right here. I told this GeoGebra app to give us square cross sections. So if you come over here and we tilt this, we start to see this 3D shape that's built by taking this triangle and using the base, that triangle as the base for our squares. So then we can start to see this 3D shape come to life. And we want to calculate the volume of this 3D shape. That's what we're trying to visualize. So to do the volume, we do the integral of the area of our cross section. So this cross section is a square, so the area is s squared. So we just need to figure out, what is s? Well, let's color code this a little bit. S is the base of my square, because here I have s squared. S times s is the area of my square. So s is this base here, which is going to be top minus bottom, what we were doing in 8.2. So the top equation is this negative 2x plus 2. This bottom is the x-axis, or 0. So my S is going to follow this equation, and that'll tell us what S is at different points in our triangle. So to find the volume, I come into here, do the integral from 0 to 1, those are my limits, of my side squared, because it's a square. So this is the area of my cross section. This times this, that's the area of my cross section, and I take the integral and I get the whole volume put together. Now, you should know how to do this sort of thing. So I'll give you a hint that this is a U substitution, but I would like you to pause the video at this point and try to solve this volume or this integral all on your own, and then come back to check and see how you did. Welcome back. Let's see how you did. You should need to add a negative 2 into this and a negative 1/2 to balance it. Then we take the integral of u squared, which is u cubed over 3. Plug in my limits. Oh, sorry, I did something wrong. Ha-ha! I forgot to plug my u back in, friends. Negative 2x plus 2 cubed. And that x is a 1. There we go. And this one should be negative 2 times 0 plus 2. That's better. Sorry, forgot to plug my u back in. Anyway, you should still end up with 8/6. Final answer. So, that is our first volume of a solid with a known cross-section problem. In the next video, we'll try the same shape, the same base, but now we're going to start to apply different cross sections to it and see what that does to this volume.